Now, let's do some cool experiments with Rover. We'll first create a circular wall on the screen using the special solid. And then we'll use the solid to create a bowl that we'll put some gunpowder in. Now let's set fire to the gunpowder and see what happens. Bang! Now let's try to create a similar structure to the one that we had before. And let's see what's really happening during each frame. Okay, gunpowder set, fire. 1 frame, 2, 3, 4, 5, 6, 7. All of those interactions, this explosion, how the sand is falling, how the wall is hit through, all of those interactions are backed up by a very robust back-end physics engine called advanced kinetics. Also, no matter how fast we draw on the screen or how complicated the lines are, we're always going to get a continuous line and there will be no dots missing out. That's because I implemented a special line function to make sure that no matter how fast we draw, no matter how fast the mouse is moving on the screen, we're always going to get a continuous line. Here's another example of a really cool science experiment, the rainbow flame test performed in Drober. So we're going to create 7 tubes to put our substances in, and then we're going to light them all. So yeah, these are all powder forms. And you see on the lower right hand, there's the description of the different color flames. Okay, almost there. Now let's set fire to it. You see, all of those flames are of different colors. Isn't that really cool? Now that we've looked at some of the cool features that Drober has as a physics sandbox game, let me show you how this is really indeed an agent-based simulation engine. Let's look at how Drober simulates the behavior between a rat colony that loves chocolates and chocolate. If I just put rats on the screen, they're going to die out because they don't have any chocolates to eat. But then, if now I try to put some chocolate on the screen, and some rats, okay, they're just going to flock over to get the chocolates. Notice how the tailing rats are going to die out because, again, they're just following the leading rat and they're going to die. Yeah, and these are 2 rats. Okay. Now let's look at a different kind of rats. These rats are a little more stupid than the previous ones. They don't really know where they're going, they behave very randomly, and this is indeed what's really cool about Drober, is that Drober allows for the random behavior of the particles. As before, if the rats do not get chocolates, they're gonna starve to death. The difference between these rats and the previous rats lie in the way that they find food. For the previous rats, they have a vision of 20. What that means is that they can see within a distance of 20 and then once they see this food, they're just going to go get it. For this kind of blinder and more stupid rat, they only have a vision of 5. And then if they don't see a food within a distance of 5, they're just going to behave very randomly until they find, until one of them finds food. And then once this rat finds food, it's going to send a signal telling all of the other rats within a distance of 20 that, okay, I found food. And then the other rats, once they've received the signal, they're just going to come to him and go get food together. There is a couple more design details that I would like to add about this project. First of all is that it's very extensible and very easy to use for any developer. You can really just create a very cool substance that does all sorts of different things and has random walk properties within just 10 lines of code. And that happens because there is a very powerful support network that supports all those substances. Second thing is that this ABM engine is completely created from scratch without using any existing ABM modules because I want it to be as efficient as possible. And to that end, I implemented multi-threading. I really spent a lot of time working on the different algorithms to make sure that they're working as efficiently as they can. There's also the saving and loading different experiments function that I did not show in this video, but yes, you can definitely test it out in the actual code. Thank you guys so much for watching.